Hey guys, welcome to lesson 17. In this lesson, we're going to talk about quadratic functions. We already talked about quadratic equations, but now we're going to talk about functions and the graphs. Okay, so there are different types of polynomials and properties of the polynomials that we will discuss in this chapter. The main thing you should focus on with any polynomial is the degree of the polynomial. The degree is the highest exponent in any given polynomial, no matter where it lies in the polynomial. So it could be in the front, in the back, or somewhere in the middle, but whatever the highest degree is, that's your degree of that function. All right, the number in front of the variable is the highest, with the highest exponent is our leading coefficient. Again, it doesn't matter where it lives; it's the leading coefficient. All right, so for a polynomial, here's some examples. We have a constant, we have linear, quadratic, cubic, quartic, and all the things. The degree for each of these is 0, 1, 2, 3, and 4. And then for this one, for a constant term, that's the leading coefficient, 2. On 5x minus 1, the leading coefficient is 5. 4x squared minus x plus 1, the leading coefficient is 4. All right, so whatever the highest power is, the number in front of that is your leading coefficient. In this section, we're going to focus on quadratic functions. The simplest quadratic function is f of x equals x squared. All right, so we have this picture to the right. Parabolas are symmetric with respect to a line. That line is the axis of symmetry, or just axis of the parabola. The point where the axis intersects the parabola is the vertex of the parabola. So we have this imaginary line that goes right through here. That goes right through the middle of it, and it splits the parabola directly in half. That's your axis of symmetry. All right, and then the vertex is where it changes directions. Also where that line of symmetry goes through. Okay. Every parent function has what we call the graphing form of the equation. This form is usually preferred form to obtain before graphing because of how straightforward it is. Below is the graphing form of the quadratic equation. So a, h, and k are all parameters that affect the parent function of the graph. A, the number a can be, if it's greater than 0, it opens down or opens up. If it's less than 0, it opens down. If it's bigger than 1, it stretches it, and if it's a fraction, it shrinks it. H is a horizontal shift, K is a vertical shift. Okay, so complete the square here to figure out what the graphing form is. Okay, and since we're dealing with f of x and everything's already on the same side, it's going to look a little different than what we've done before. So let's take a look at it. So we got f of x equals x squared plus 2x. And I'll leave some space and say minus 5. Now, half of 2 is 1, and when you square 1, you get positive 1. So we put positive 1 next to the x's, and since everything's on the same side, I'm going to balance it out by saying negative 1. And that's the difference from what we did before. Okay? So here, when I factor this is going to be x plus 1 all squared, and then we got minus 6. This is the graphing form. And so my vertex is going to be negative 1, negative 6. My axis is going to be x equals negative 1. Because remember, the line of symmetry, or the axis of symmetry, goes directly through the vertex of it, and we're going to use the x value. Okay, so my domain is all real numbers, right? And this comes from the fact that up here it says domain is all real numbers. And so my domain is negative infinity to infinity. All right, above the parent function, the range was 0 to infinity. All right, so we need to know, did I move at all from the origin? Well, it turns out I went down 6. So that means my range is now going to be negative 6 to infinity. Okay, and then we graph it. All right, we got negative 1, negative 6. All right, so there's that. There's no number out front, so it's a really basic parabola. Nothing special about it. It just, where does it start? So that's that. And that's really just a rough sketch of it. Number 2. We have f of x equals All right, we're going to pull the 2 out front. And so this is going to be x squared plus 1/2 x plus something minus 6. Now, because, and this is why we did it in a previous lesson, we made those first, when talking about circles and completing the square, we made sure that the leading coefficients were 1. This is how it affects it if you don't do what we did. Okay, so we are half of a half is a fourth. And if I square a fourth, I get 1/16. Now, I'm not subtracting 1/16. I'm subtracting by 2 times that because of that 2 out front. Okay, so let's clean this up. So I got 2. When I factor this is going to be x plus 1/4 all squared minus, and then 2 times 1/16 is 1/8. And you can subtract that, so that'd be 48/8 for the 6. 6 is 48/8 minus 1/8. And so this is going to be 2 times x plus 1/4 all squared minus 49/8. Okay, so that's my equation. And my vertex is going to be h and k, so that's going to be negative 1/4, negative 49/8. And my axis is going to be x equals negative 1/4. My domain is still all real. And my range is affected by the up and down movements. Okay, so I went down negative 49/8 units. And so my range is going to be that value and up. So negative 49/8 to infinity. Okay, and then let's see, I got negative. Let's see, 1, 2, 3, 4. Let's be negative 1, and then I got 1, 2, 3, 4, 5, 6. All right, so 48/8 is 6. So 49/8 is going to be just over 6. So like right here. And then I got the 1/4 right here. So this is going to be my point. And then the 2 is going to stretch it. So it's going to be really thin. It's going to be really thin. Okay. Again, this is just a sketch. It's not exact, but that's the idea. All right. 3 will be the last one we do in this section, but it's the same kind of thing. I'm going to pull the 2 out of the x's. So I got 2 times x squared plus 2x plus 5. Half of 2 is 1, so I got plus 1. And then I got 1 times 2 because of the 2 out front. All right, so this is going to be 2x plus 1 all squared plus 5 plus 2 is 7. Okay, so that's my equation. Let's see, that's going to be 2, or it's going to be negative 1/7 for my vertex. My axis is negative 1. My domain is still all real numbers. My range, this time I went up 7, so it's going to be 7 and up. 7 and up. Okay, so here, oops, that should be minus that. So 5 minus 2 is plus 3. Okay, so once I fix that, now my graph looks like this. I got negative 1, 3. And again, the 2's out front, so it's going to be really skinny. All right. So that's the idea. And that's the idea of quadratic functions. That's it for this lesson. Reach out if you need any help, and I'll see you in the next one.